Let's talk about resolving vectors. So imagine today we have vector A here, and this vector A, if we put it on an xy coordinate, it's not lying on the x-axis, nor is it lying on the y-axis. It's somewhere in between the x and y-axis, and here I measure the angle between the vector A and the x-axis to be theta. Okay, if I wish to express this vector, write it down in mathematical form or expressing it in words, it will be something like this. So the vector A will be something, let's say 5 meter, and this is theta above the positive x-axis, like what we discussed in the videos which we learned how to express the direction of vectors. So now, resolving vectors, it's something that we do very often when we are dealing with calculation of vectors. What we do is we split this single vector A here into two components. Okay, so a 2D vector, this is a 2D vector because it involves x and y dimension. A 2D vector consists of two components. So one component will be the x component, one component will be the y component. Okay, so resolving vectors, it's a step where we split a vector into these two components. So we split the vector into the first component lying on the x-axis, the second component lying on the y-axis. So we find how much of this vector A is lying on the x-axis, how much of this vector A is lying on the y-axis. We're finding the two components. So if we resolve A, then we won't be writing our vector this way anymore. We will be writing it as AX will have something something, AY will have something something. Okay, just something to be careful here. If you notice, A here has an arrow pointing to the right. Means by this A here, it's a vector. And we are writing both the magnitude and the direction to represent this vector. But now you see, when I split it into components, I have AX and AY. And both AX and AY have no right arrow as the head for AX and AY. You can't see any right arrow on top of AX or AY. So in that case, what does that mean is AX and AY here are not a vector. Okay, if it's not a vector, when you are writing your value here, you don't need to write the direction anymore. Okay, so in this case, AX is, let's say, 2.5 meter, AY is 2.5 meter. You can just stop there. You don't need to write towards the positive x direction, towards the positive y direction. You don't need to write those things anymore. Okay, so that's components. Let's look at another example. Now let's say we have a vector B, and if you put it on an xy axis, then it's somewhere at an angle from the negative below the negative x-axis. So we should express it in words or in mathematical form. It will be B equals to something something, and it's theta below the negative x-axis, right? Because this is a negative x-axis, it's below the negative x-axis. Okay, again, we are going to do resolving vectors here. So we are going to split this vector B into components that are lying on the x-axis and components that are lying on the y-axis. How do we split it? We draw a line perpendicular to the x-axis. We draw a line perpendicular to the y-axis. We are splitting it this way. You can see I'm cutting 90 degree onto this y-axis line here. I'm cutting 90 degree to this x-axis line here. So drawing this dotted line tells us that how much of vector B is in the x-axis, in the x direction, how much of the vector B is in the y direction. Okay, technically you can see if we do Bx, if we do Bx then do By, we will eventually end up with vector B. That's the idea. We split how much is in x, how much is in y. So the steps of resolving B, we'll get bx equals to something something, by equals to something something. Okay, so here are a few facts about resolving vectors. If you're resolving vectors, right, the y-axis and the x-axis must be perpendicular. If you are resolving a 3D vector, then you'll be resolving into x, y, and z. But mostly in our syllabus, it's x and y only. But x and y must be perpendicular. Why? Because you don't want these two components to be related to each other. What do I mean? If your, let's say today your y-axis is like this. Okay, if your y-axis is slanted like this. Okay, I'm using my laser pen here to show y-axis. If my y-axis is slanted, then when I split into x and y, movement in x is having some component of y. In that case, that's not independent anymore. That's dependent on each other. Movement in x will cause movement in y. We don't want that. As you can see here, if my x and y are perpendicular, like right now, any movement in x will not cause any movement in y. Okay, any movement in y will not cause any movement in x. That's independent. Okay, so it must be perpendicular so that x and y can be independent. But by combining x and y, we are able to get back our vector b with a correct angle. That's the idea of resolving vectors. Okay, so in the next video, we'll be talking about skills or maths that you need to understand in order to resolve vectors.